See, one second. UML. First, write down what is the definition of UML. Okay, UML is Unified Modeling Language. Okay, it is a graphical language. It is not at all a programming language. It is a graphical language which is used for modeling purpose only. It is Unified Modeling Language. It is not at all the programming language. It is used for graphically representing the various elements of the software. Okay, now after writing the definition of UML, why you need to model? What is the importance of modeling? You need to write. What is the purpose of UML means? Nothing but you need to write what is modeling. Why? What is the purpose of modeling, or what is the advantage of modeling? Already in previous class I have discussed about the modeling, right? Okay, why you need to model? With an example you need to explain. You can take technical example or general example. Modeling is nothing but creating some new structure which expresses, or which expresses the complex system. Okay, modeling is nothing but new creating a structure which expresses the complex system. Structure is nothing but you need to show diagrammatically various elements of the complex system. Why you need to model like this? Why can't you explain theoretically? Because if you show in some diagrammatic format, at a glance at a glance you can view what is the components of the system. Okay, how the system will be, how the system will behave, you can visualize it, right? See, if theoretically, if you are explaining theoretically, how can you understand at a glance what are the components present in the complex system? It takes lot of time, right, for you. Okay, so if you represented in some diagrammatic format, it you can visualize what are the components present in complex system, or what are the components present in inside the components, subcomponents, or what are the components which are present in complex system. You can visualize it at a glance by seeing that diagram, or by seeing that pictorial representation of various elements of the software. And also you can understand what is the behavior of the system, how components will communicate with each other, what are the sub components present in the system. Okay, by modeling some view of the sorry by modeling nothing but some representing pictorial representation of various elements of the software system, so that you can visualize the components present in the system, and also you can understand how the system will behave. You can understand well, very well. And also, if you represented these in some models, nothing but some structure, class structure, object structure. Okay, if you draw some diagrams, UML diagrams, it will help. It helps for you in constructing phase. Nothing but while implementing the system, it acts as a blueprint. It helps you to implement. Okay, I hope you understood. And also it helps for documenting. Okay, it also helps for documentation purpose. I hope you understood. Once you need to write sorry first you need to write what is UML, definition of UML, and then UML is nothing but unified modeling language which is used for modeling purpose. That's why you need to write what is modeling and what are the advantages of modeling. You need to write. After that, explain with an example. Take some general example, or you can take some technical example. For example, take some general example. If you are constructing some house, okay, if you are constructing house, what civil engineer will do? He will draw the plan, right? Nothing but where the master bedroom will be there, where the kitchen will be there. He will draw. Without modeling, he cannot construct, he cannot start constructing, right? You won't accept it. You should know how the house looks like. If you want to know how house looks like, he want to show that civil engineer must show where is the master bedroom, where is the kitchen, where is the hall. You must know, right? Okay, so civil engineer will model it, will draw the plan of the house, and you must accept that plan, right? Because you are the owner of the house. Okay, you must accept that plan, and you must know where will be the rooms, where will be the master room, all those things, where will be hall, all those things you need to know and you need to accept it, right? And then only construction will start, right? In the same way, if you want to explain the if you want to explain what you're developing to the client, you need to show, right? You need to show diagrammatically so that he will understand well. If you are explaining theoretically, how can he understand? He can't you can't explain, right? Theoretically he can read, but he should, at a glance, he should understand what are the components, how system will behave, how that client will understand. He can't understand without modeling. Okay, that's why you need to show diagrammatically by drawing the UML diagrams, use case diagram, class diagram, all those things. Okay, so that client will understand what are the components of the system, how the user interacts with the system, all those things are present in modeling, right? So once the client is accepted, you can develop the system. If client is not accepting, you can't develop the system. If client want to accept it, you need to express what are the elements present in the complex system, how user will interact, all those. How can you show? You can show using UML diagrams. I hope you understood. In this way, you need to explain with general example. You need to take general example. I hope you understood. Or take some technical example. Each and everything you need to explain with example only. Without example, you don't explain. You don't write. Don't write points. You need to explain each and everything with example. Okay. Uh, just wait. Students, is my voice is clear? Students, is my voice is clear? Students, is my voice is clear? Okay, okay. Okay. Now, you have to write, after writing definition, and then you need to write what is the importance of modeling and advantages of modeling with an example. Take any other example, general example or technical example. Just now I have explained an example by taking house, constructing a house. Okay. Next, you need to write, here question has asked like this: things, explain about things. See here, you need to explain about things. Okay, see these three things, sorry, these three are the building blocks of UML. Things in UML, diagrams in UML. Here in question I have asked only things, explain things. See here. Okay, things, write down. See here, first you need to list out. Don't start writing what are structural things, what are behavioral things. First list out. After listing only, you need to explain each and everything. See how many things are there: structural things, behavioral things, grouping things, annotation things. Okay, now let us see each and everything. Structural things, these are statical parts, static things, okay, which represents elements, physical elements of the system. Class, interface, first list out like this. Don't write explanation, first list out like this: class, interface, collaboration, use case, activity class, component, node. First list out, after then explain each and everything. See how many structural things are there: 1 2 3 4 5 6 7. Seven structural things are there. How many things are there? Totally four things. Coming to structural things, there are seven things. Now let us see. Already you know this, right? See how to represent class. Example of a class. What is class? Already we have explained all those things. I have explained. I'm sorry. Already I have explained. Once again, see the PPT. Okay, next. You need to explain. Now see here, interface. See, interface is nothing but it is collection of operations, methods. Collection of operations, methods. Okay, no implementation, no body for that functions or no body for that method. Just some method names, just like display, something like that. Just methods, it contains only methods, no implementation part. Okay, like this, no implementation part, only methods. It is collection of some operations, methods. Now someone must implement those methods. Okay, remember that interface is a collection of operations only, no implementation details. Someone must implement. Some class must implement the operations. Okay, see how to graphically represent circle and then name. Example, see here. Now, collaboration. See, collaboration is represented using dotted oval, which contains interaction of the classes along with their role. Interaction of the classes along with their role. Next, use case. Already you know all those things. Use case. First, write down the definition of use case. Okay, nothing but functionality. Okay, functionality. Use case. Use case is a description. It's nothing but you need to capture the functionalities. Okay, functionalities which contains each use case represents some sequence of actions in it. Okay, there will be some sequence of actions to be performed. Example, login. There are some sequence of operations to be performed, right? What you will do, you need to enter. See, this is an action, entering username. Username you need to enter. Password you need to enter. Username, one second, username. You need to enter username. You need to enter password and then you need to submit, right? So these are sequence of actions. There are sequence of actions. If there are sequence of actions, capture it as use case. Nothing but some functionality of the software, right? It is some functionality of the software. All the requirements you need to capture as use cases. Each use case represents some sequence of actions performed in it. Example, login, place order, enroll seminar, enroll to the course. Examples. Next, active class. Active class is nothing but uh, active objects. Active objects means the objects which communicate at the same time. That means it should exhibit concurrency. Concurrency. What is concurrency? Several tasks executing at the same time. That means the object contains several threads. Okay, threads are nothing but is also piece of program only. It is also piece of program only, but it executes. It is a separate execution unit. At the same time, okay, at the same time, several tasks will be executed. This is active object. It is heavily threaded. Thread is nothing but it is a piece of code only, but it will execute separately. It is a separate unit of execution. That means many tasks will be executed at the same time. Active object which communicates at the same time. Here concurrency concept will come. Okay, next, component, which is replaceable part of the system. Component must be indicated like this. Graphical representation. All graphical representation are important. You need to remember all those things. Next, node. Node is also a physical element, but uh, sorry, one second. It should have some process memory, and it should processing power. It should have some processing power. Example, server, printer, internet, pc, personal computer. It will have some memory, and it should have some processing power. Okay, it is also some physical component. I hope you understood. These are the things. These are the things. 7 kinds of things, structural things. Next, behavioral things. See, once again, see how many things are there? 4 things: structural things, behavioral things, grouping things, annotation things. In structural things, again, there are seven types. You need to explain each and everything graphically and with at least 2 examples. Next, behavioral things. These are nothing but interaction. How interaction takes place. What is the statement? Sorry, what is the state mission? What is the interaction? See here, interaction is nothing but if one object want to pass message to other object, there must be some interaction, right? Interaction is nothing but passing messages. How to represent graphically? Just a solid line, nothing but bidirectional. If there is arrow symbol, one object is invoking method of another object. Okay, interaction. How graphically you need to represent interaction? Solid line. Okay, there may be a direction also. Next, state mission. When state mission, see, just first see graphical representation. Graphical representation of a state mission. Rounded rectangle. Inside that, you need to specify the name, state mission name. See, when you want to use this, when an event is triggered, or when there is a transition, okay, from one state to another. Here you need to represent state mission. It represents the object lifetime. Okay, see, every object will have the state, right? It may change from one state to another state. At that time you can represent the state mission. Or when an event is triggered, at that time you can represent the state mission. At that time you have to represent the state using state mission. Next things are grouping things. Nothing but, see here, package, where all the related classes are grouped together. It is nothing but package. All the related classes are grouped together. You need to represent like this, package name. See the graphical representation. Symbols are important. You need to remember all those symbols. Next, you need to explain with an examples. See the examples. Next, annotational things are nothing but those are explanatory parts. Explanatory parts. See, example. Sorry, not an example. How graphically it is represented. How graphically these annotational things are represented. Here you can write some comments. You can explain the things, okay? You can write the comments or some guidelines, whatever it may be. Okay, some explanatory part, some textual content. And see the graphical representation. This is nothing but note. Graphical representation of a note. Okay, completed. Okay, you need to write these things for this question. I hope you understood. Next question. Sorry, next question. See the next question. Explain the relationship and common mechanisms of UML with examples. Now you need to explain what are the relationships and what are the mechanisms of UML. How to write it. Just wait. Yes, see here. 1 second. Relationships. There are 4 kinds of relationships. First, you need to list out all the relationships of UML. There are 4 kinds of relationships: the dependency, association, generalization, and realization. Okay, now let us see. Next, uh, next, graphical representation. Write down graphical. 1 second. Graphical, representation. Present neatly. First you need to list out like this, and then you need to write graphical representation of dependency, generalization, association, realization. See here, dependency. How dependency is graphically represented: dotted lines, arrow mark, arrowhead. Okay, dependency, dotted lines, arrowhead. Next, association, just a solid line. There may be direction also. Just a solid line. Association, link. Association is nothing but a link. Next, generalization. See here, generalization. Draw a solid line and then draw a triangle. Triangle points to the superclass. Generalization, inheritance. Next, realization. See how graphically you need to represent realization. Dotted lines, and then you need to you need to draw triangle. This points to the superclass. Not superclass. Just wait. I'll explain with an example. At that time, you can understand. See, after writing this, after drawing this graphical representation, you need to explain with an example, at least 2 examples. You can take more than 2 examples also, but at least 2 examples you need to explain. Let us see here. I took only one example, but you need to take at least 2 examples. Dependency. Here, server is a class. See how to represent class, rectangle. And here I just used only one compartment. Here, first compartment in this, you have to use class name. What is the class name here? Server. Next, I took another class. What is that class? See here, class must be represented using rectangle and draw a compartment. Here, I have used only for one compartment. First compartment here, it contains class name. What is the class name? Database manager. Now see here. Here, server is a dependent on database manager connection. Okay, if server want to implement its operations, then what it must there must be connection, right? In order to implement its operation, server is doing, server is using the database manager using. Okay, see here, stereotype use, you need to write what is the relation using, who is using server. Okay, dotted dotted line and then arrowhead, dependency which shows dependency. Server is dependent on which one? Database manager. Next, association. See, association is nothing but some link between, see, person places order, right? Now here there must be association name. What is the association name? Place. Okay, you can represent some arrow mark. Who is placing? Just like this arrow mark, or just like this. Who is placing? You need to know, right? Who is placing order? Person. Okay, next, write down multiplicity. One person can order one dot dot star, one or many. Okay, he can order many items, right? One person can order one or many items. And what is the name of the association? You need to, this is the name of the association name. Association name, you need to specify what person is doing. Person is placing the order. Next, generalization. Next, generalization, nothing but inheritance. See here, flower, rose is a flower, right? If there is a relationship, it is nothing but higher inheritance. Generalization here, flower is generalized. Generalize, flower represent, this flower class represent generalization, rose class represents specialization. Okay, here if there is a relationship, what you need to do is just write down generalization. Its relation is generalization. Inheritance here, all the properties of flower class. See here, rectangle is pointing to flower class. That means rectangle, sorry, triangle, right? I'm so sorry. Triangle. Triangle, yes, so triangle only, right? Triangle is pointing to flower. That means flower is a superclass. Superclass. And rose is a subclass. What rose is doing? Rose is acquiring all the properties of flower. Rose is a flower. If there is a relationship, then it is a generalization. Here, superclass is called generalized class, and a subclass is called specialized, because uh, rose will have some additional properties, right? Rose will be used in some beauty purpose, right? Or in health also. See, there are some additional properties. That's why it is called specialization, specialized class. Okay, this is specialization. Coming to realization. See, realization. See here, here there are two classes, printer class, printer setup. Here there will be some methods, right? Methods of printer class. Here the printer setup is implementing the methods of printer. Okay, see, printer setup class is implementing the methods of printer class. Printer class contains only methods, no implementation details of those methods. Who is implementing? Some other class is implementing. Printer setup is implementing the methods of printer. This is what realization is. You need to explain with an examples, at least two examples. Now let us see next one. Okay, common mechanisms are there, right? Okay, let us see common mechanisms. See, these are the common mechanisms in UML. List out first. You need to list out the common mechanisms. How many common mechanisms are there? Specifications, adornments, common divisions, extensibility mechanisms. You need to list out all these things. After listing, you need to explain. First, write down uh, First, just explain what is specifications. For every icon there will be a specification. For use case there will be specifications. For class there will be specifications. For every icon there will be specification. Specification is nothing but detailed description. Let us take a class. Here I took class. Explain at least with two examples. Which class I took? See, circle. Okay, circle is a class. A rectangle, draw a rectangle, and then here I have drawn only one compartment. See here, one compartment, okay, which contains class name. One first compartment contains class name. Now for this icon there will be detailed specification. What are those detailed specifications? See here, these are the detailed specifications. Nothing but you need to specify uh, attributes along with their data types also. Float or double. Not one second. Float. Okay, float. Float something, double or float, or your wish. Okay, along with the data types, along with detailed attributes, detailed methods, along with access specifiers. Minus represents, you need to explain what is minus, what is plus, you need to explain. Okay, what is minus? Access specifier private, access specifier public, plus access specifier protected, ash symbol, you need to explain also theoretically. Okay, for function also write down the data types. Find area like float, returning some float value or some double value your wish. Okay, you need to represent, you need to specify in detail. Next, coming to adornments. See, add-on general meaning means making attractive. Add-on means general meaning of add-on means making attractive. Now let us see, for every icon you can specify some adornments, nothing but some notes. Okay, like this. One second. See, this is a note. This is a note. You can attach a note for each and every element like class, all those use case, all those things. Okay, object, you can attach a note. How to attach a note? See, what is graphical representation of note? Rectangle and corner there will be some triangle symbol, and then draw like this dotted lines like this. You are attaching some explanatory parts for this class. Okay, next, common divisions. See, the common divisions nothing but class and objects. Here I took faculty class and objects. So there will be object, right? Without objects, we cannot access all these members and data, right? Okay, objects. Here I took Lavanya. Lavanya is an object. See graphically how to represent an object. Draw a rectangle and then draw a first compartment. In that first compartment, you need to specify object name. What the object name I have specified? Lavanya. Next colon. Keep the colon. And next specify the class name. Okay, and next specify the class name. Lavanya is an object of which class object? Faculty. Next, another object. Here I took Kamala. Kamala is an object. Which class object? Faculty. You need to specify object name and then faculty. Okay, I hope you understood. Next, interface and implementation. See here, you know what is interface? Interface is collection of methods, no implementation. Just it contains only methods, no body for methods. Who must implement? Someone must implement those methods, right? See, faculty is implementing the interface A methods and interface B methods. In this way, graphically you need to represent what this diagram is specifying. Faculty class is implementing methods of interface A. Faculty class is implementing the methods of interface B. Students, is it clear? Are you able to understand what I am saying? Students, are you able to understand what I am saying? Are you able to understand? Are you able to understand or not? Please respond. Okay, okay. See, at least you need to write two examples and you need to explain all these examples. What is Lavanya here? You need to explain like this. Here, Lavanya is an object. Lavanya is an object of which class? Of class, of class faculty. In this way, theoretically, you need to explain what you have drawn. Don't draw simply like that and leave it. You need to explain each and everything in examination. Okay, again, coming to interface and implementation, after drawing, you need to explain here like this. Here, faculty is a class. Faculty is a class. And next point, you need to explain faculty class is implementing the methods of interface A. Next point, faculty class is implementing the methods of interface B. In that way, you need to explain each and everything. Next, extensibility mechanisms. Okay, there are some extensibility mechanisms, stereotypes, tagged values, constraints, all those things. Okay, see here. Here you are extending the class event queue. Here, see, exception is a class. Okay, here you are writing some stereotype like exception. Stereotypes in this way you need to represent less than symbol and then name of the stereotype and greater than symbol. Two greater than symbols is nothing but stereotype. This is also class only, but it is extending of an existing class. What is existing class? Event queue. This event queue, if there is an exception, what is that exception? That exception will be executed. What is that? Overflow. When this will be executed, if there is an exception, right? Okay. These are nothing but some extensibility. These are not original classes. These are derived from other classes. Okay. Exception. Remember, the stereotypes must be represented in less than symbol, two less than symbol, name, and then two greater than symbols. Next, tagged values. You need to represent tagged values in between open curly brace value and closed curly brace. Here, see here, event queue. See the tagged values. Version equal to 3.2, author equal to something, some other name. Just like that, you can represent uh, tagged values. Some additional information. You are tagging some values to the class in open curly brace and then give values and closed curly brace. Tagged values, some additional information you are giving. Next, constraints. These are some limitations that every class must satisfy. Just for example, see here. See the limitation. See the constraints. How you need to give constraints. Open curly brace, constraint condition, and close curly brace condition. See here. When a person will become senior member, see this constraint. P dot age. Here P is an object of person. P dot age is greater than 60. When person's age is greater than 60 only, he will become senior member. I hope you understood. Or you can see, you need to write at least two examples. Bank account. Bank account secure portfolio. Portfolio. Okay. Just an example. Bank account secures portfolio. I hope you understood. Here, constraints are nothing but some restrictions, some conditions. You can add like this also. Open curly brace, condition, close curly brace. I hope you understood. In this way, you need to explain each and everything. Diagrams, you need to draw the diagrams and you need to explain those diagrams. See here, for example, see this stereotype. See, you have drawn this diagram in examination. See, after drawing, you need to explain here. Class is event queue. Event queue. The methods of the class are add, remove, flush. Okay. And then you need to explain about the stereotype exception. I hope you understood. You need to explain each and everything. Next question. Illustrate the modeling of system architecture with neat. Illustrate modeling A system's architecture with a neat sketch. With a neat sketch, you need to explain the system's architecture. Let us see it. Okay, see here. System architecture. There are 5 views of the system architecture. You need to draw the diagram and then you need to explain each and every view. This is the system architecture. Okay, first view, design view. Here you need to explain what is design view, what is implementation view, what is deployment view, what is process view, what is use case view. All these things explain it. Okay. See, again, there are many questions. I need to explain all those things. Okay. See, next, class diagram. See, already I have explained, right? No need for explanation of design view, use case view. There are some, you need to list out the use cases, right? Process view, you need to test all the performance. Deployment view, you need to see the topology of the hardware, all those things. Okay, you know all these things. There are many questions, I will explain that. Okay, next, create the class diagram of library management system by following some common modeling techniques. See, for every diagram there will be some common modeling techniques. Okay, you need to follow those common modeling techniques. You should not draw directly class diagram. Create class diagram of library management system by following the common modeling techniques. I have given assignment also. I hope you all are doing the assignment, drawing that diagrams. See how to draw. In examination point of view, how to draw. Let us see it. One second. See here, when the question is asked like this, don't draw class diagram directly in examination point of view. In assignment also. In assignment, I have given assignment, right? Assignment 3, I hope all are doing it. You need to submit in, you need to submit on Saturday. Saturday, you need to upload it. Okay. Now, see here, you need to draw, you need to list out like this, common modeling techniques of class diagram. No need to list, just write down common modeling techniques of class diagram and write first point. What is the first point? Modeling simple collaborations. Okay. Modeling simple collaborations. What you need to do? Modeling simple collaborations means, see here, one second. Just wait for one second. What is this? Not one second. Please wait. Okay. See, first you need to identify the classes. First, you need to identify the classes and then identify the responsibilities. You can identify the attributes also. Simple attributes. Attributes. The next compartment will be methods. You can identify simple methods. Don't identify uh, detailed specification. Don't write detailed specification in first stage only. You need to identify what are the classes. Library management system, right? I'm sorry, library management system. One second. Classes for one second. One second, wait for one second. Okay. See, first identify library management system. First identify the classes and responsibilities also. Here I didn't mention responsibilities. First identify the classes and responsibilities. No need to identify detailed specification like this, plus, minus, all these things. Simple attributes, simple methods. Identify and identify the responsibilities also. See, all those methods you have identified must fulfill the responsibilities. Okay. Now, see, after identifying the responsibilities, what you need to do? See, first see the classes of library management system. See, before drawing the diagram, you need to understand what is library management system. Who will be interacting with the system? There will be users, right? First, you need to think of that. Before drawing the diagram, first think about the system. Who are the actors? Who are uh, um, who are interacting with that system? Who will interact with the system? Library users. How many types of users will be there? Two, faculty and student. Okay. And what again, what are the responses from the sorry, what are the operations we are going to do? Okay, issuing a book, requesting a book, and librarian issues a book. So how many actors are there? User, nothing but faculty, student, librarian. So take three classes. See, first thing, who are using the system? Just think like that. Who are using the system? Who are the users for that system? Student, faculty, and who will be there? Student and who will be there? Librarian. Just take that classes: student class, faculty class, librarian class. And next, think about the operations. What student is doing, what librarian is doing. Okay, requesting a book, a librarian must issue the book. All those things identify. Now what are the parts present? One second. Here in library books, there will be books, right? Okay, so identify book class. After that, uh, just identify the operations. You need to log in, right? After login, what you are going to do, you need to search, you need to see whether book is available or not. If book is available, what you are going to do, you need to request the book, and librarian will issue like this. Think, just think, don't draw the class diagram. Just think for 5 minutes about the system. Just think, you will get the classes and you will get a relation between them. After issuing a book, what librarian will do? He will check the due date, right? If there is a due date, you need to pay the bill. Sorry, you need to pay the fine, right? Okay, you need to pay the fine. That means you need to do some transactions online. This is online library management system. You need to do some transaction. Okay, he will show the bill. This much amount has been, this much amount is recorded. He will show the bill. A bill will be generated. You need to do transaction. Now you got the classes, right? It's very easy. Just think about the system. Who are the actors and what are the operations you are doing? Now you got the classes, right? What are the classes? Librarian class, book class, transaction class, bill will be generated. So bill class. Okay, member record, nothing but there will be student and faculty. That's all. And now identify the attributes and then identify the methods. Okay, see here. One second. This is not moving. One second. Okay, see here. Now coming to the member record. Coming to the member record, every student and faculty will have the ID, right? Write down the ID. Type. Type means student or faculty. Date of membership, number of books issued, all this, name, address. Okay, all the attributes of the member, write down. After that, write down the operations like issuing a book. Okay, increasing or decreasing, paying bill, retrieve the member. All these things are operations. You can write your own way also. Don't by heart all these things. Think what are the operations. Just like request book, or increase the request or decrease the book issued, pay the bill. Members are nothing but students and faculty, right? What are the operations they will do? Think like that and write down all those operations. Don't by heart. Don't by heart what is present in the PPT. Just write down on your own way. Next, coming to librarian. Librarian, what are the attributes of librarian? Librarian will have the name, user ID, just like phone number, email address, all those things he will have, right? Write down all those things. And what are the operations that librarian will do? He will search for a book, whether book is present or not. Verify the member. You are requesting, right? He need to check whether you are the member of the library or not. Verify the member, issue the book, calculate the fine, generate the bill. written book. Okay, he should accept the book, right? He, after returning, he will see and he will calculate the check. Sorry, he will calculate the fine, right? Okay, I hope you understood all the operations. What librarian will do? Think like that. What user student will do? What faculty will do? Just think. You will get the operations. Write down on your own way. Don't by heart whatever present in PPT. Next, coming to book. See, book. Every book will have an ID, right? Author of the book, name of the book, price, publisher date, all those things. Write down all those things. And next, see, every book will have some book details. Okay, book details, book status. Okay, display book details. If you want to see, for example, you want UML book, there is a there are some links. UML, sorry, what is this? One second. Something UML, some CD, something like that. You want to click this, right? If you are clicking this means you will get some information of UML authors, all the UML books. There are many, there will be many authors, right? Okay, that means it should display the book details. There will be many UML books, many authors, right? It should display all those things. That means there must be an operation. If you are clicking this UML link means you should get all the books available or all the books related to the UML. Okay, I hope you understood. That's why there must be some operation to display it. So display the book details like that. Think like that. If you know how the system is working, then you can write in detail. Okay, you can identify the methods in detail. Next, transaction. Transaction will be ID. Who is transaction? Who is doing transaction? Member ID. Book ID, for which book you are paying the bill, that book ID, all those things. Create transaction, delete the transaction, retrieve the transaction details. All these things are methods. Next, bill. There will be bill number, date of the bill, whose bill, member ID, whether student or faculty, amount, how much amount you need to pay. Okay, all these are attributes of the bill. Create bill, update bill. Who is doing all those things? Librarian will do, will create the bill. Who is going to do transaction? Member record, nothing but faculty and student. Now, see, there will be a number of books like journals, magazines, study books, okay, study materials, all those things. Okay, now, you need to draw completely. Identify like this. Modeling simple collaborations means you need to identify like this. First identify the classes and then identify the responsibilities, simple attributes and method, and then you need to, one second, one second. In detail, you need to draw like this. In detail, follow the modeling techniques. First, identify the classes. First, identify the classes and responsibilities, and then identify with multiplicity. Okay, this way. In detail, with relationships in detail. All detail specification along with plus, minus, access specifiers. Uh, you need to represent with multiplicity also. See the class diagram. See the class diagram. Now see here. I will explain one by one. Part by part I will explain. See this one. See book. See here, there will be many books, right? Journals. What is journal? Is a book. Magazine is a book. Study book is a book. There is a relationship. If there is a relationship, it is nothing but generalization, inheritance. What is the symbol you need to use? Solid line and then triangle symbol. See here, triangle symbol must point to the superclass. Here, what is the superclass? Book. So here, journals, magazines, study book will acquire all the properties of a book class. Okay, next. See, no need to explain all those things. You can just simply draw the diagram. That's all, like this. First, identify the classes like this and also identify the responsibilities and then draw the class diagram. Follow the modeling techniques. Okay. Now see here. Uh, See the relation between the book and librarian. What librarian will do? See, solid line. There is a solid line. Issuing book. Who is issuing? Draw a arrow mark so that you will understand who is issuing the book. Librarian issues the book. Okay. Next, relation between. See, write down the multiplicity also. One second. See here. This part I am explaining. This part I am explaining. This part. Okay, this part I am explaining. See, write down the multiplicity. There will be one librarian, right? One librarian can issue one dot dot star, many one or many books. He can issue one or many books. It depends upon, see, for any individual, there may be constraints, right? You can write down the constraints also. Just like he can issue more than only two books, sorry, less than two books, not more than two books, like that. Some constraints, if you want to in detail, if you want to do, you can express the constraints also. Okay, each faculty or each student must request two or three books only, right? There will be some constraints, right? You can specify those constraints also. That's your wish, but in detail, if you want, you can represent those constraints also. See here, now multiplicity. See, multiplicity must be there. There must be the multiplicity. One librarian can issue one dot dot star, one or many books. Next, member. Now I will explain the member. See here, this part I'm explaining. This part, see here, student is a member, right? Student is a member, faculty is a member. Here, what is the relationship? Is a. If there is a relationship, means there is generalization, inheritance. Okay, how to do it? How to graphically represent? Draw a solid line and then represent a triangle triangle only, right? Yes, triangle symbol. Triangle is pointing to member record. That means it is a member record. Is a super class. See, no need to explain like this. In examination also, no need to explain. Just draw the diagram. First represent these classes and then responsibilities, and then draw the diagram in detail. No need explanation theoretically. Just explain two or three points. That's your wish. Okay. Now see here. What is the relation between the member and the book? Member will request a book, right? Member is requesting the book. There will be one or many members can request many books, right? There will be many members, right? There will be many students. There will be many faculty. Star. Many faculty can request many books. See, you can write some constraints also. That's your wish. Now let us see relation between bill bill and member. Who is paying the bill? Who is paying the bill? Member, right? Student and faculty, right? So write down solid line. Draw the solid line and write down name. All these are names of association. You need to write the names of association also. Okay, pays. Member will pay the bill, right? Okay. Uh, next, next, a relation between bill and relation between bill and librarian. Let us see. See, who will create the bill? Librarian, right? See, so the relation between them is solid line, and then name is create. Who is creating? Librarian. Okay. I hope you understood. This is the class diagram for library management system. In assignment, I have asked 1, 2, 3, 4, 5, 6 class diagrams, right? In this way, you need to write. Don't draw class diagram directly. Follow the modeling techniques. First, identify the classes, identify the responsibilities. Okay, and then draw the class diagram in detail with all specifications. Is it clear, students? Is it okay? Is it clear? Is my explanation is clear? Is my explanation is clear? Students, is my explanation is clear? Please wait. I had to take attendance. I request all the students to please wait. I didn't took attendance. I need to take attendance. Please wait. Don't leave the class. Please wait. I will say when to leave the class. I'm taking the attendance. 25, 54 members. Okay, students, you can leave the students. You can leave the session. 57 only. Okay, students.